Okay, my name is Mike Smith. I'm a program manager for data services, and I sit around thinking about things like data access, provisioning, and integration with external systems and other exciting things. What I'm going to do is talk to you about the TV server provisioning system. This presentation will familiarize you with the provisioning portion, which is an area that generates a lot of questions on the product, and it will also give you some new terminology for some of the changes, and I'll mention some of the changes as we go along. For example, TV server provisioning system is named to cover what we used to call WADL, the Web TV Data Access Layer or system or whatever you want to call it. And so that's the first change. So it's now TV server provisioning system, and what I'll do is a lot of things I've had in the past with third-party vendors and with customers, the wording would come up that we'd talk about provisioning, and then we'd say it depends on what you mean by provisioning. So what I want to do is start off by talking about provisioning itself, come up with a set of let's say a general definition of the term provisioning system, and then we'll talk about the TV server provisioning system. I'll mention what it is in words. There could be a couple bullet slides, and a little bit on the benefits of the provisioning system. And then we'll get into architecture, where I'll give you thousands of words in the form of pictures. Pictures worth 1,000 words. And so we'll start high-level architecture and work down into lower-level architecture until your head starts hurting. Then we'll talk about server groups and scaling out to large populations of customers, and then a little bit about the building event store. Okay? And feel free to ask questions as they come into mind, because this is an area that a lot of questions do pop up. Okay, provisioning. What I did is when I started out, I decided to look in the Microsoft Computer Dictionary under provisioning. It's not in there. I looked in the Telecommunications Dictionary, didn't find anything on provisioning, and I searched the web for provisioning, and there are a lot of vendors out there that write software for provisioning, but they assume that you already know what provisioning means. So I looked in the web dictionary and found these two little bullets amongst many under the term provisioning. One of them is providing, preparing, or supplying for a future need. Okay. The other is preparation, preparatory arrangement taken in advance, sort of a setup, a preparation for something. We use the term provisioning in two general contexts when we talk about TV server. One of them you'll hear mostly from BART, and that's in setting up the connection when you're establishing you're logging in and connecting to the service. You're provisioning the connection as you're setting up. And there's the other one is the service one I'm interested in is service provisioning, where you're actually setting up data in specific data stores of service providing systems, such as the TV server database, and you're setting information there in preparation for future consumption of the service. Okay. Now I want to define a phrase, the service provisioning system, and I call a service provisioning system the infrastructure by which service information is prepared and maintained for an entity such as an account or user or device. The important distinction is provisioning is the preparation of it. This is the part of setting up, but I'm also including maintain. So when we talk of data services, I'm including that in the provisioning system. So we don't have to say we're calling it a provisioning system when I'm talking about provisioning. We're also calling it the data server when I'm talking about data system, data access. Okay.
Question. One thing that's not really clear to me, I've talked to a lot of people about provisioning, but when a client box fires up and it gets recognized and connected to a server, is provisioning happening then, or is provisioning something that has happened before that?
That's the connection provisioning I was talking about. It's where you get an IP address, you have access.
So provisioning happens both before. Provisioning is both preparatory and in real time.
Yes, and in fact, when BART talks about provisioning, that's the providing and pairing for the future need. The future need being the connection, the bandwidth, and setting it up to access the service. Mine is more of an arrangement made in advance to set up the placeholders for the user or for account in the database.
And would actually, we've had this discussion many times, their view of provisioning is when you phone and say, geez, I wouldn't mind to get some cable.
Right. And that's
their provisioning
And that's the provisioning that I'm interested in and I'll be talking about.
They have to see the whole cycle through. We're actually just one part of that cycle. And we need to keep relaying what part of that cycle we are to the whole cycle. If we just talk about it in the context of our little cycle, they got it and we lose the battle there.
Okay, thanks. Okay, so let's talk about the provisioning system, or the TV server provisioning system. I put TPS here, but we don't have any official abbreviations or acronyms. Okay, sometimes we have a very few acronyms, and sometimes acronyms are great, and we want to get many. So here, what the convention is taking on is, if you're writing out the provisioning system in some document or in some paper or something, you can make an abbreviation for shorthand, and you put it in parentheses. But it's not really I don't want to stand and say this is the official abbreviation for the provisioning system. Anyways, TV server provisioning system is a modular and flexible. By flexible, I mean extensible and scalable general provisioning engine. Okay, so we could have, I guess, early on, a provisioning system, a custom provisioning system, could have been made for TV server that is only interested in the TV server service, but it was decided to build a general engine so that because the service arrays multiple services for the consumers, it's more integrated, more coordinated to have that provisioning done by a single engine. Other examples of provisioning engines would be, we have a customer, AT&T, that's contemplating the use of a general AT&T provisioning engine that we would just connect to. Another one would be Xeon Corporation, used to be called Firstel, has a product called Net Express, and it's only interested in provisioning. So it's a provisioning engine, and we would gladly tie up with that, our provisioning engine, and just let delegate the provisioning work to them. Anyway, out of the box, the provisioning system provides all service data provisioning and the maintenance needs to operate TV server. Okay? Not to say that to operate TV server business, because it doesn't cover billing. It doesn't handle billing things, but you can operate everything right out of the box. And so one task you would do if you want to operate a TV server business is to integrate your billing system to our provisioning system. It provides a simple API to allow access for viewing and modification of service data. Okay, it's a simple object-based API. And this API provides the information, the service data, in logical entities called profiles. And a profile is an aggregation of information, a particular class of item. Like, for example, a user profile will have all that information, such as first name, last name, phone number, mailbox name for that particular user. Okay. This helps to hide database implementation details, so applications and services that need data does not need to know about the structure of the database, and they don't have to worry about integrity and things like that. In fact, when you get the data and you're accessing properties of your profiles, you don't necessarily need to know that one of the pieces of data may come from a different system than the rest of the data. Okay. And it allows integrators to add in other data resources, external resources, such as homegrown, in-house, or third-party billing systems, subscriber managed systems, and other services like email, directory services, and so on. Okay. Now we're going to get into pictures, not very many words. This is sort of a simplified picture of the interaction that's in this world of this provisioning system. What we have is multiple application services are consumers of data, service data. For example, customer service, the CSR application, home pages, the logon service. And then we have service profile objects, or SPOs. And these service profile objects are those entities I'm talking about, a user profile, subscriber profile. And the old name for this thing was TDAL, and before that was WADL. TDAL stood for the TV Pack Data Access Layer. So it's a data access layer, but since you're working with objects, I think it's a better name to call it a service profile objects. Okay? And examples of objects, devices, users. And then there's a SCO server, which used to be called MAPS. MAPS for the end MSys administration and provisioning system. And so since MSys isn't in the product, we thought it was like a slightly misnomer. And yeah, or yeah, either that or we were naming it. Well, it was really the Microsoft administration and provisioning system. So it's kind of a corny name. So this is more appropriately named the SCO server because it serves up SCOs, and SCOs are service configuration objects. These are objects that are concerned with back-end data resources, whereas the service profile objects are concerned with providing data to consumers. Okay? An example of a SCO would be the SQL SCO that comes with out of the box that accesses the internal database, service database that we have. And you can write custom SCOs to access your billing systems or email provisioning and so on. Then these SCOs interact with resource managers such as a database, an RDBMS like SQL Server or Oracle or Informix, or other subscriber management systems or billing systems, Active Directory, and other services. And we'll get more into the context picture here. This is a high-level architectural picture of the provisioning system. On this side of the picture, you have consumers of service information or service data, and then here you have managers of or providers of this service information. Here we have examples on applications that TV consumers access, or server components like the registration services that access the initial call setup and connection. They access data out of here to find, say, information regarding a key to get your session keys for authentication. And then a customer care application, like out of the box we have a CSR tool, which is a canned application, but any other customer care tools that is used to integrate to the system. They would instantiate provisioning service profile objects, through the use of a broker. So they would create an object called a broker and then send me a profile on this user with this particular account number or login ID, and so on. It would access the SCO server, making requests to the SCO server. SCO server would look in and based on the type of object and the action that's required, such as add or update, we'll put together the sequence of steps that needs to be done to execute that job. And a SCO is essentially a step in that job. So you sequence, say, 2 of these SCOs and then execute those. And the SCOs worry about how to access. So all the API information, all the details on how to access this back-end system is encapsulated in the SCO. Okay? So that SCO is run, and whatever operation is executed on that. Okay, a little closer look. This is inside the server now. This is the consumer part again, the applications, and this is the back-end part here. These two. And this shows more of the interactions. By these arrows, the arrows mean this entity initiates communications or requests to the other entity. That's where the flow of the arrow. So an application would request data from a profile object. Profile object would get information out of the profile dictionary that would give template information on profile, like what does profile look like for a particular type. Say, what does a subscriber profile look like? It provides the information or receives information from the application in an add operation, and then when the application says, I want to add this to the database, the first profile object sends a request to this SCO server. The SCO server takes the request in, goes to the dictionary, and finds out what are the steps needed to this particular task. Then it sequences the steps and executes them, and bundles the responses from each one of those and sends a response back up the chain. Here's where the SCO server manages, sequences the service configuration objects. Here's a depiction of the SQL SCO that you come out of the box, and the custom SCO that you would write your back-end billing system. For an integrator deploying TV server, their task would be to integrate their system into TV server, and here are the integration points, the 3 of them. If you're just going to do, say a light level or a high level integration between your system and the server, one of the first things you would consider is how would you talk to the TV server. And you would use the service profile objects in your building system to send data to the server. You can integrate more tightly by having the server talk back to your building system. So in order to do that, we have you have to have some agreement on what is your server going to say or do to activate things on my server. So you would have an API for your building system, some programming interface, and we have a set of rules that if you follow the rules, if you write a particular type of software fragment or chunk and install it in a certain way, then whenever we need to access your system, this function will be called, and suddenly you'll have control and you can do what you need to do to execute, say, an add or update or retrieval of data. Does that make sense? Okay.
The only thing I noticed is you don't flow into the application.
Into this goes?
Into the application. All in the top.
Well, the flow is, see, it's a request response sort of thing. So the application will make a request. Now, response would come back to the application with data.
Yeah, that's why you just have a double.
Right. But this is not to show data flow. It's more to show the who's initiating the transaction or the request. And then building system, we also have service profile objects. Broker itself will allow you to throw what's known as building events. The integrator would define building events, go into the dictionary, and enable these events so that an application can say, well, this event occurred, someone will this event information to the system. So when it's thrown into a building event store, which is a SQL Server database, it's a table with some management infrastructure in there. For example, we watermark it so that when you pull events out of it, you have a place marker so that you would know where we're at, and you can pull events. We can archive the old events. And the building system would just retrieve in SQL those events. Okay? Simple building event model. It's not really real-time events. It's fast events because it's it's a relational database in SQL Server, but it's not real-time in the sense that there isn't a two-phase type of commit mechanism where responsibility of the event is handed off and assumed by the receiver. We may work on something like that in the future, but there hasn't really been a demand for that. Okay, so that's the architecture of these TV server profiles, provisioning system. Any questions on it? Any curiosities? Okay, so when you're in the booths or whatever, and they're asking you how do I integrate my systems, these are the three things to worry about. Writing a scope to talk to external systems, which is sort of like 20% of the integration work. I feel that 20 or 30% of the population is going to want to do that level of integration. Most of the integration is going to be that system sending information and commands to the TV server. Okay. All right, service groups. With the provisioning system server, I pictured it earlier acting a database. That database can be on the same machine as the provisioning server, or you can have multiple provisioning servers for a larger population, all accessing a single database. Okay? We have, I'm going to introduce another thing called a local routing database, or the LRD. The local routing database will allow you to, will come into context or is useful when you're talking about multiple service groups, because once in a great while you may have the need to access data for a user that's not in this database. You need to find out where to go to get the data. So this is a general service group. So multiple service groups would look like this. You set up an array of provisioning system servers that accesses a database, a service database. And notice the service database is an external thing to the server, the provision server. And then you have multiple copies of the database. And you have the LRD, or local routing database, that would get replicated information from a global routing database. So most of the time, say 95% of the time, most of the accesses on these servers will access the database here. During initial setup, is about the only time I'd anticipate that you don't know the service group. These service groups would have names, so you don't know the service group of a particular user. You do a query to the local routing database. Most of the time, it'll be in this service group, and so you keep that information in the ticket that goes around to different applications. So when an application requests data, it would send with it the service group that it's in, and you would know to access the data out of that database. Once in a while, we may get a request, and the LRD says, "Oh, you're in another service group," and so accessing it because of this replication, you would know service group, and you would access the database here from this provisioning system server. Okay. So this feature can grow and grow and grow to handle millions and gazillions of users. Okay, so that's the provisioning service side. Now there's also building event store back here in this diagram. Okay, which one? This one? Okay, service groups. The on the
the way that things generally get provisioned in a cable operator, for instance, the customer service rep will do it in their console, right? And then that'll be, depending on how it's architected, it could feed a number of different systems. We're one of those systems that gets fed to. It gets fed to. So we don't show that anywhere, though. We just show our own world, which is within TV service.
right.
Right?
Yeah, for that.
You show the billing world, but you don't. In billing, you show the external world, but you don't show the internal machine world.
Right. This is just this illustrates the I guess service groups. The service groups is a concept for the database itself. So the service it's relevant to have just the service database here. Right. The question on how do you how does the billing system come into this when you integrate?
It's not how the billing system is. Where are all the other provisioning systems sitting?
Okay.
Cable operator has, or the network operator has.
Where are the provisioning systems?
So
Right.
if they're using the HBO channel, they're not doing it through ours. They're doing it through they're doing it through, same with, well, let's just take an example. The GI, right? So the GI head end, you got a GI controller, you got a GI box. They have a provisioning system that says, I want to watch, I phone up and I say, hey, the fight's on, I want to subscribe to HBO, and the customer service rep says, great, Quinn, your critical will turn you on. So, right?
Okay.
So they have to actually go in, turn my HBO channel on. That's got to get that's their business system has to talk to the GI controller at that end. Then it talks to my set-top box running MSTV, my set-top box, and turns HBO on.
Right.
So that's one example of an entire event of provisioning that comes through that doesn't use our software, but yet still writes the sensors.
Right.
Set-top box.
So I guess the paraphrase of that is that the service provider, the cable service provider, has many services, an array of services that they need to provide and provision. And I view that in I guess in levels of integration. What levels are the different provisioning systems integrated to the TV server provisioning system? It's either not integrated, two separate systems, or integrated through a mediating provisioning system that we would talk to, or it is actually integrated into our provision server to do some of the tasks. And so for those different ones, the easy ones to talk about would be the ones that aren't integrated. There would be the person that does it would go to another screen and do something else. The ones that are integrated with a general provisioning engine from Xeon or something like that, you would have picture a cloud here, and these servers accessing that cloud, and the cloud is accessing all the other services and provisioning. Integrated one, you write a particular service configuration object for, say, a billing system, a subscriber management system. You would have an arrow coming out of each of these servers going to that billing system. Okay, and so out of all servers, and they won't really be organized into service groups unless you build that into the integration code. Right. Well, in the future, currently, that's how the picture would look currently. But in the future, we're going to have this notion of a remotable service configuration object. So you station the service configuration option at the billing system, and all the arrows disappear. And then when any operation needs to configure it, will go and actually execute on that billing system. for now, it's sort of a distributed thing where all the servers will do the configuration and know about that billing system. That was a question, by the way. Okay. Billing events. Earlier diagram, I showed a little cylinder here for the billing event store way off in the corner. It's a little table. Just throw events in. But for scalability, what we have set up is multiple billing event stores based on service groups in general, but they can be by server themselves, and they would do replication to a central billing event store. This is something that an integrator would do, and we provide documentation assistance and perhaps scripts and doing some of the initial setup. And the idea is that billing events would occur throughout this the service, and as they occur, they get placed in this billing event store, which tracks it by record ID, which is a monotonically increasing number, so you know if you're missing any events, and you can keep track. So you're sort of guaranteed your events in that way. And as it gets replicated to this, there's another tracking number that keeps track of all of those. So here, you access your data, pull it out. There's a watermarking scheme here, and that watermarking gets updated on each of these servers. So at all times, the stores have an indicator of what events you've already seen and what events you haven't seen yet. Okay. This is a general picture. You can have individual servers accessing a billing event store. You can have a provisioning system server accessing an event store, or an application server, because the broker itself, the service provisioning object, is profile. I'm sorry, is what's accessing or throwing the events. So the event can actually come from an application server. And in the context, this service profile object doesn't have to be on the scope server. It can be on the application server. And that's what I'm saying. So you can have an application server throwing events, and you can also have a client application, a custom-written, Visual Basic application throwing events. Okay.
Mike, just out of curiosity, when a client request comes in, where does it first process that?
You mean an event that's thrown? The events are sort of just a blob that's grabbed, a string that's been thrown into a store. So as far as a client request, the request is just throw this event, and the event ends up here. So what's the question?
Well, actually, my question is more relevant to
for service.
a few slides previous when you were the slide with service groups.
Okay.
Yeah, well, you've got multiple TPS servers, right?
Mm-hmm.
And then you have a SQL server. Does the SQL server determine which of those TPS servers is going to process a particular,
No, the SQL server will request and respond to the request. So this particular server is an application that's homed to this provisioning server. Provisioning some server will make its request, its profile object request for data, and they would request it through OLADB or whatever to the SQL Server store. It's the SCO that would know what server to go to.
In a service group, does each one of those TPS servers, are those duplicated, that they're the same services on each one of those TPS servers?
Yes.
Okay.
And they would...
So what determines which server is going to provide the service?
The complex services infrastructure will do that. So when I access one day as a consumer, I may not necessarily access it the next day. Consuming part of it. But this server, it would go to this database server for its data. Okay, and then also in the group kind of thing, it would know to look in the LRD in case that it doesn't know the source group that it has to get the information from. Okay, so this LRD also the question came up when you look at this is, does every request for data result in two separate requests for information? And it's no. This is just for the exception, the 0.5% of the time where you don't know, like for example, an initial connection, you don't know what group it's in, and then it's a larger amount of time for that. But going across to another server would be a very small percentage of the time. Okay? Any other questions? Okay. That's,
Okay.
yeah,
So,
lunch, now we...
let's go ahead and get lunch, come back, and then